Differentiating from first principles, part 4.
Let's say that we want to differentiate the function sine of x. Now we know that that normally differentiates to cos of x. So now to differentiate this from first principles, we need to use the equation, and we know that f of x is sine of x, and therefore f of x plus h is sine of x plus h. Plugging that into the equation, to carry on doing this calculation, we have to use second year A-level maths. Using the compound angle formula, sine of x plus h is equal to sine of x multiplied by cos of h plus cos of x times sine of h. And of course we take away sine of x. Filling in the rest of the equation, now we apply the limit as h tends to 0. Let's look at cos of h first. As h tends to 0, that means cos of h tends to cos of 0, which means that it will tend to 1. So cos of h is tending towards 1 is more or less equal to 1. So really we have sine of x multiplied by 1, which is just sine of x. Now to look at sine of h, we need to use our knowledge of small angle approximations. So at really small angles, sine of theta is more or less equal to theta. That means as h gets really small as it tends towards 0, sine of h is more or less equal to h itself. Sine of h becomes effectively h, so we have cos x times h. Simplifying this equation, the sine x's cancel out, and then also the h's cancel out. What we're left with is the answer, which is cos of x, and that's it. We've differentiated it from first principles. Brilliant, George out.